Hi guys, hope you are doing good. So today we'll be continuing on our next lecture. That was our PyTorch project. So guys, specifically what we are trying to do is we are trying to do a deep learning project. We are trying to do a deep learning project uh, specifically with the help of PyTorch. So guys, what we had done last time is we had some data and we had done some data cleaning. Okay, now we had done all these things in the last class, so please watch the last lecture because guys that would really give you a sense of it. But even if you want to just skip that, you can skip, because what I'm essentially doing is, if you'll see the first step over here, I'm writing the date processed file into my staging path. So let me explain you this as well. So what happens guys, whenever you're working on a project, you will probably have three paths. One is raw, second is staging, third is curated. Some people also called it bronze, silver, gold. And guys, there must be some other naming convention as well, but mostly these are used. So the thing is that guys, whatever raw data set you have, right, whatever is your data set which is raw, it's present in the raw or bronze one. Then guys, we what we do is we do staging. That means we do some sort of cleaning on our data set so that now it can be used further for analysis or model building. And that kind of a thing is dumped over here in the silver or in the staging layer. So we have dumped our data set into the staging layer. Okay, that's done. Now we are just trying to read guys that in the daytime you will find index at an hourly gap, and this is the column that we need to focus on, that is global active hours, since we'll be using the next set of columns, that is 1 2 3 4 5 uh, 6 and extensively 7 as well. So I'll tell you what the problem statement is guys. Understanding the problem statement is very important. So see, what we are trying to do is we are trying to build a time series model, and guys this is just for your demonstration, okay, not for accuracy development, since that part would come later, since this is more to just give you a flavor of how things are done. So what we'll be doing is we have 7 variables. Okay, based on 7 variables we would be predicting one variable. Let me explain you how over time you will understand this, okay, as in when we'll move forward in the coding line. But yeah, I'll explain you here only line by line. So see guys, what we are trying to do, we are trying to import libraries, and then we are trying to do min max scalar over here. That means what we are trying to do exactly is that we are trying to standardize our data set. Okay, so we are trying to standardize our data set. So what we are doing is guys, we are doing something known as min max scalar in the first step of our main code. So what does min max scalar do? There's a formula, that's x min x max minus x min. So whatever data you have, right, it goes through this set of transformation and then it is in the range of 0 to 1. Now the question is, why do we need to do this? Guys, essential what usually happens in neural networks is, okay, you need to convert everything into a certain range so that your gradient calculation becomes very easy, at least in terms of scale. So what usually happens with the neural network is, I in my lecture I've been mentioning a lot about this equation. Okay, rate of change of loss with respect to w old. So this equation is very important guys. Okay, you just need to focus over here only, that what we are trying to build over here, rest all is okay. You need to focus mainly on this equation, and the gradient calculation becomes very easy if your data is scaled. Okay, that means it is of the similar magnitude, because if one value is 700, another value is 0.1, so it becomes very difficult for the model to actually do gradient calculation and then convert. So that is why we do this min max scaling, and this is the formula for it. So guys, let's just move to the next step that we are doing. What we are doing is we are defining sequence length. So guys, what we are exactly trying to ask the system that, hey, I'll be giving you 24 hours prior information for 7 set of variables, and based on this 7 set of variables you need to predict what is known as global active power. So based on past 24 hours I'll collect the data, and then I'll ask it to predict what would be my next global active power, so that I can do basically my time series analysis and my power prediction, so that I can like decide anything, whatever I want, whatever I don't want, right? All on those lines can be delivered. Okay, so that's there. Now what is happening guys is that if you will see what we are trying to convert our data in a way that what we have, if you will see, let's just run this code. Yeah, so what you're seeing guys, what for the time being I have done is I have just like converted my data set into a format so that I'll have x and y in a particular format. So let's just see x and y. So what is x? X is your 7 features, 1 2 3 4 5 6 and 7. So this row is exactly the first row, if you would see. Okay, this is exactly, I think this is not the first row, but yeah, this is some row in the data set. And if you'll see the next corresponding y value, okay, sorry guys, this would be the first row in the data set only. It's just that it's scaled down, so that means it is like scale after min max scaling into the range of 0 and 1. So that is my first row, and this is your x vector which has first row, and this has second. This, if you will see this is past 24 hours of data. And what is this 0.551? This is the 25th observation. Okay, so let me just explain you that what we are trying to do over here in terms of tensor manipulation. This is important guys, because this would be the main task that you would be doing. Rest all code and all is not very difficult, that you can find over the internet as well, or chat gpt or anywhere. So see guys, what is the tensor manipulation? What we are doing is we are trying to convert our, so in our whole data science journey we deal with something known as x and y. Okay, x is the independent variable and y is the dependent variable. Okay, like this is the target variable. So based on our x we need to predict y, right? So what we are doing over here is we have taken this, and this length is 24 cross 7. Okay, what does this mean guys? This means that I have observations or data for the past 24 hours, and based on that I need to predict what would be then my next or my global active power in the 25th hour. Okay, so that is how the data formatting is being done, that these are the first 24 rows and then this is the next row that comes post that, because based on this data I need to learn how to predict the next one. Okay, so this is some sort of time series analysis. So guys, here what we are doing, we are just trying to like manipulate the data, and I explained you how, and only thing we are doing is tensors. I have taught you tensors. And then guys, we are doing a train test split, a simple train test split using the basic train test split, right, where we are manually just trying to divide the data into 80% in the training and 20% for the testing. I think this is good. Now guys, just try to understand what we are trying to do over here. This is the main line of code. Okay, so first of all guys, let me just go over here. So let me just explain you once. So what we will be trying to do is we'll be focusing on using a GPU. Okay, so here I'm using Colab, and Colab is offering me a free T4 GPU. Okay, so I'll exactly make a detailed video on GPU as well, but for the time being, let's just try to understand something about GPU in the quickest possible fashion. So yes, we have been using GPU a lot and we'll continue using it since it really helps us in matrix multiplication. And it's just that it has the property of parallelism, which just accelerates the calculation, right? So for the time being, this much knowledge is there. That is why we are using a GPU. So that is there. So extensively, this CUDA is nothing but it's a driver which NVIDIA has, and it's installed on all NVIDIA's GPU, and we use it. So this is okay. Now guys, what we are trying to do is we are trying to split our Y data by using dot view -1 and 1. So guys, if you are from sklearn background, you must have seen this error view -1 and 1. So guys, see what happens is that in PyTorch, the loss function expects your target to be in a certain format, okay, and that format is nothing but it is a column vector. So what is the property of a column vector is, if you've seen anywhere, a column vector would be something like this, like point 0.3, point 0.2, point 0.1. So this is how a column vector looks like. So this one, that is the number of columns, is this. That means you would always have one column in a column vector. And guys, this -1 is just that the fact that you need to infer the number of rows automatically based on the size of the variable. So all you need to remember is that whenever you wish to have any target thing, just try to implement dot view -1 comma 1 on top of that, because what it's going to do is it's going to convert it into a column vector with the specified amount of rows, and always the column length would be 1. So we have done that as well. And then guys, we are taking it onto our devices, which GPU. And I'll probably have a detailed lecture on GPU explaining how it came and everything. So the next part of the game is that what is our input size. So I've been explaining you very carefully that our input size would be 7 guys. We have 7 columns in the data set, and based on those 7 columns for the past 24 hours, I need to predict the global active power variable. Okay, this is my problem statement. Okay, so we have done this as well. Now guys, what we are doing, this is the power of PyTorch, because how simply in one line of code you can just write your LSTM module. Okay, all I'm using is LSTM with 2 layers and one linear layer to transform the data. So let's just come over here. So see guys, so I won't be like talking about LSTM in depth because that would be a long, but just see LSTM means long short term memory. Okay, so guys, the main idea is that it is a neural network that's based out of RNN family. The second main point which you need to know about LSTM is that it uses something known as gates. Okay, and the main thing is that what was the issue with RNN? So the main issue with RNN was long-term dependencies. So it was not able to capture the long-term dependencies very well. So what LSTM does it uses something known as gates, and it helps the system to capture long term dependency little better than RNN. So you need something on those lines, right, for a time series based model, because time series data has uh, a factor of like a factor of just the fact that you need to remember past information, right? The past information is important in order to predict the future information, right? Because the thing is guys, time has meaning, right? Because let's give you a basic life example. At 3 like at 8 at 9 a.m you do breakfast, then you do study, right? So it's like the time has a pattern or a trend which the system needs to capture. It's not like anything can happen anywhere. So that is why we are using an LSTM. And see guys how simple, only one line of code is required. We are just having 64 hidden layers and 2 layers of it. Sorry, this is the number of neurons in the layers, so 64 neurons, and we are just trying to use a dropout of 0.2 so that we don't have overfitting, and then we are just transforming it into a linear layer. So see guys, whenever you're trying to do a regression problem, you need to have the last layer as a linear layer only, so that if you have like this kind of a neural network structure where you have 64 here and 64 here, everything just gets like connected with each other, and like everything just boils down to one neuron, so that we could have our output coming here for regression. Okay, so we are doing that as well, that's also done. So guys, now we are just trying to write a predict function that what will happen is that once you will pass your x variable to this thing, then it's gonna have the last output. The last output would get extracted by this. So guys, this you need to understand that this would help you, this portion of the code would help you extract the last portion from the last hidden layer of the LSTM, and then you just need to pass it to the linear layer. Guys, then we have been doing this exactly many times, that you need to define a loss function and an optimizer for just your back propagation. And then guys, I'm just defining the number of epochs is 100, the batch size is 32, and best loss as float in. So guys, the main thing is that again we are doing if you would be remembering, in all my lectures I've been talking about something known as mini batch training. So what happens is guys, you split, let's say you have 100 records and you create a batch of 10 records. So in one run your data would be sent and would be converted into 10 like it would be converted into 10 batches, and then one time like one batch would go to the neural net, another time second batch would go to the neural net, and this process would happen approximately till nth batch, which is 10th. So we need to do batch like batch wise training, because guys this is more efficient, because we would be not running into a case where we have a lot of memory, because I'm just using a free GPU and free compute, so there would be some limitations on it. That is why we are going for mini batch training. And guys, I've been doing this again and again, right? Output, loss, epoch, I think this you should have remembered till now, that this is how it happens. You need to get the forward pass, compute the loss, have a backward propagation, and then just we are mentioning, okay, we are not doing anything that's great, and guys we are just saving the model into a dot pth format. If you would see how the model has run, and see if you have power prediction model dot pth. So guys, this is the main thing. If you would see over here, see prediction model dot pth. So even I can share this file with you and you can play around with it. So let's just try to understand what happens over here as well. So guys, this type of things is very common, that whenever someone trains a network, they usually at times share a .pth file. What is this? Has all the parameters information that I have used in the code, and also the model weights. Now at inference, okay, at inference, what does inference means? So at inference means once you are using it for prediction, you don't have to retrain or do anything. You can simply just copy paste the architecture what you have used, copy paste the architecture what you have used, and then just try to get it along. So what we are trying to do over here guys, we are simply just trying to copy paste the, so someone has given us this .pth file, we are just trying to copy paste the model architecture. We are just defining the loading saved weights, we are just defining the scaling parameters, because guys see, I'll explain you this as well. So you remember, right, we did this thing x min x max minus x min, right? So we have done some sort of scaling. So the same scaling factor needs to be applied at test data as well, so that we'll have the model see the same set of stuff which it has seen in training. I hope you're able to understand it, right? And guys, then we are just trying to do torch.nograd, that means make prediction without computing gradients, and we are just doing predictions. This is a very static code, you can just try to have a look at it. There is nothing difficult over here. All we are trying to do is we are loading the model, defining the same architecture, and just transferring the weights from that pth file to our architecture, defining the scaling parameters, because once we'll do the prediction, right, we need to do inverse scaling so that the format is very close enough that we have to what is required. So guys, just try to see what happened. We trained a neural network and something, this kind of a chart is coming. So guys, this lecture is very important, most important lecture. If you'll see this chart, Let me just try to see if I can draw it over here. So there is this, then you have the training loss, and then you have the test loss. So let's just go to my board. So if you're able to see, guys, this is nothing but this is your loss and this is your epochs. This is your training loss and this is your test loss. So you're able to see that your training loss is constantly decreasing, but after certain epoch your test loss has started to increase. So guys, this is the perfect case of overfitting. Okay, now I'll be giving you a homework. Try to incorporate techniques such as early stopping, dropout, and maybe play around with some optimizers and some learning rate scheduler. All these things would cover, we will cover in the course as well. We have already started, like we used dropout over here. So what happens in dropout is that, let's say you have something like this going on, and let's say you tend to drop out like, let's say 10% of it. I'm just giving an example. So this connection would get cut out, but just try to explore that how do we deal with overfitting in terms of neural networks. Here we had 27,000 records. Are they less, or they are definitely not more, but are they less? Is the data even had some sort of relationship which could have been captured by a neural network? So all these things are very foundational and prior to your understanding of things such as, like, why do we need to use a GPU, and how do you define an LSTM, and how do you get stuff done. But just try to stick to the basics, because here there's a very important insight that has come up, that after this epoch the validation loss is going up. That means we are overfitting. So just spend some time in trying to understand this situation and this chart, guys. This is very important for you guys, because exactly in future you won't be writing any code and all. Okay, as I said, that coding will mostly be not a thing. There might be some engineering level coding which you will do, but the main thing that would be, like, if you want to like train a LSTM and all, you can just copy paste the code like I did, and it's just that how it's going to be. But you need to be a little experimentative in order to understand more and more things, so that you could get stuff done in a more efficient manner. Okay, so let's just try to conclude this lecture by giving you a brief of our project. So you're able to see that we are able to get some predictions as well. If you'll see, power consumption minus 0.01. Power consumption can never be negative, so you need to apply some sort of logic over here as well. So these are your set of homeworks. So what are we trying to exactly do over here in this project is, first of all, guys, what we did, I'll give you a project overview and project journey. Project overview, what we did is, we had a CSV file, sorry, we had a txt file in this case. So we had a txt file. We first cleaned the data set, then we dumped it into our staging directory. Then, guys, we read the data from the staging directory. Then we applied some sort of transformations, and then, guys, we converted our data set into tensors. And then, guys, we defined the architecture for our LSTM. Then we trained an LSTM, and then we dumped the model as .pth file. And then based on this file that we have, we are able to make inferencing. That means we are able to do some real-time predictions as well. And what we have realized, guys, that our model is overfitting. So we have covered a lot of important concepts, guys. Try to see specifically this point is very important, because what we are trying to do is that we are trying to load our PTH file directly for inferencing. So our model parameters, right, in terms of weights and other things, are all what we are doing. We are just directly like transferring it into here without actually training any neural net, and then we are doing some sort of real-time prediction. Obviously the model is not very well trained because it's overfitting, and even it's giving power and negative sense. You need to write few concepts, but the main thing is, guys, you understood the project flow. That was my main goal. So this was a very important section for PyTorch. And guys, please stay tuned for important lectures. And guys, a very important thing for you all is try to figure out stuff on this overfitting. And guys, there's one very important thing that I offer which no one offers. You can reach out to me on Instagram or LinkedIn directly, guys, if you have any doubt in anything. Simple. Lecture, any career thing, anything you want to reach out to, directly DM me on LinkedIn or Instagram. I'll be able to answer all your queries. Thank you, guys, and have a great day ahead. Bye. Please subscribe, guys.